Welcome back to Organic Chem Clinic, where chemistry becomes crystal clear. In this video lesson, we are diving into one of the most exciting topics in chemistry, which is redox reaction. By the end of this video, you will easily understand how to identify oxidation and reduction in seconds, and you will never miss a question in your exam again. What is redox reaction? Redox reaction simply means reduction, oxidation, reaction. It is a type of chemical reaction where one substance loses electron in the process called oxidation, and the other substance gains electron in the process called reduction. Note that every oxidation process must be accompanied by a reduction process. Think of it as electron exchange, where one atom becomes a loser, that is oxidized in the process, and the other atom becomes a winner, that is reduced in the process. In redox reaction, always remember these tips: oil, rig. What does oil represent? Oxidation is loss of electron, and rig represents reduction is gain of electron. Oil, oxidation is loss of electron. Rig, reduction is gain of electron. When more electron is added to the parent atom in the process called reduction, the charge tends to reduce. But when electron is removed from the parent atom in the process called oxidation, the charge tends to increase. How do we identify redox in equation? Let's test it out with some simple examples. We have a very good example of combination reaction right here. We have elements combining with another element to form compound. That is combination reaction. The parent atom here is sodium atom, and we have another parent atom which is the chlorine atom. Both are electrically neutral. That is, at this state, they do not have charge on them. When these two parent atoms react, atom A gives up electron to atom B, which implies that atom B gains or receives electron from atom A. Can we identify atom A? Atom A is a metal, which is a sodium metal right here, and atom B is chlorine atom, which is a non-metal. Metals donate electron and the non-metal receive electron. Therefore, when metal donates electron to non-metals, the metal becomes oxidized in the process, and the non-metal that receives the electron becomes reduced in the process. So we have exchange of electron in every redox reaction. The sodium atom donates one electron to the chlorine atom, which implies that the chlorine atom receives one electron from the sodium atom. So when atom A donates electron to parent atom B, it possesses a charge, and the charge is a positive charge, and it becomes A plus. And the atom B that receives electron from atom A becomes B minus. So can we look at our equation right here? The reaction between the sodium atom and the chlorine atom to give sodium chloride. The sodium atom donates electron to the chlorine atom, and what we have on the product side, we have Na plus and Cl minus, which indicates that the sodium loses one electron to chlorine, and chlorine gains one electron from sodium. So when parent atom loses electron, it possesses a charge or charges. Like for instance, let's look closely at this chart right here. This 3 plus implies that the parent atom loses 3 electrons to a neighboring atom. The 2 plus implies loss of 2 electrons. 1 plus implies there is loss of 1 electron, like we have in the case of the sodium ion right here. When parent atom has no charge on it, that is electrically neutral, it will have oxidation state of what? 0. So when a parent atom possesses a charge of -1, it implies that it has gained 1 electron, just like we have in the case of the chloride minus right here. And also, when we have gain of 2 electrons, the charge on it becomes -2. When there is gain of 3 electrons, the charge on it becomes what? -3. Take note of the ions that we have right here, depending on the exchange that we have between parent atom. When there is gain of electron, it becomes negatively charged. When there is loss of electron, the parent atom becomes positively charged. Make sense? Let me give you another example tips. Leo the lion says girl. Leo the lion says girl. Okay, what does Leo represent? Lose electron oxidation. And what does girl represent? Gain electron reduction. Make sense? Now let's consider the oxidation state of the parent atom before combination. The sodium atom here has oxidation number of 0, while the chlorine atom has the oxidation number of 0 as well before combining. For combination to occur between these two atoms, there must be exchange of electron. The sodium atom donates 1 electron to the chlorine atom, and the sodium becomes Na+ in the process. Therefore, we have a positive 1 oxidation state for the sodium, and the chlorine that accepted 1 electron from it has a -1 oxidation number. Now, can we indicate the oxidation process and the reduction process? We have an increase in oxidation number or state is oxidation process. So I have 0 to +1 oxidation states implies oxidation process because we have an increase in oxidation number. So this is oxidation. Why 0 to -1? That is a decrease in oxidation number from the chlorine right here to this. This is a decrease in oxidation number, and it is what? Reduction. So we've been able to identify the oxidation process and reduction process in this combination reaction. Note that we can separate this combination reaction into 2 half equations, that is the oxidation half equation and the reduction half equation. Now, can we write the oxidation half equation? We have sodium going to Na+, okay? The next thing is to balance the charge. The charge on the sodium right here is 0, while the charge on the sodium here is +1. So 0 to +1 is oxidation. We need to balance the charge right now. So I'm going to add 1 electron to the sodium ion here. So +1 - 1 equals 0. So we've been able to balance the charge. This is oxidation half equation. Can we take the second half equation, which is the reduction half equation? I have Cl going to Cl-. That is, the parent chlorine atom right here has oxidation number of what? 0. That's right. So the chlorine right here has oxidation number of -1. So we have 0 to -1. Where do we add our electron? In order to balance this charge, I will add an electron to this side. So we have 0 plus -1, that is -1. And here we have -1 for the chloride ion. Therefore, this is a reduction half equation. Okay, do you know that we can obtain our overall equation by adding the two half equation? Let's do that now. In order to achieve a perfect addition of these two half equation, the electron on the left hand side of the equation will cancel out the electron on the right hand side of the equation, because the number of electron gain is equal to the number of electron loss in the two half equation. So we have Na, the sodium atom, which is the parent atom for the sodium, plus we are left with what? Cl going to, we have the sodium ion right here, plus what? The chloride ion. So we've been able to obtain the overall equation that we actually started with. Makes sense? So when we put the two half equations together, what we get is called redox. Reduction, oxidation, reaction. Makes sense? Also note that metals give up electron and develops what charge? A positive charge. While the non-metal gains electron and develop what charge? A negative charge. When a parent atom lose electron or give up electron, they become oxidized. Therefore, substance that is oxidized is said to be what? The reducing agent. Reducing agent. While substance that is reduced is said to be what? Oxidizing agent. Note that for exams, metals becomes oxidized when they lose electron, and the oxidized metal is said to be what? A reducing agent. While non-metals becomes reduced when they gain electron, and the reduced non-metal is said to be what? An oxidizing agent. Also, electron is found on the right hand side of an oxidation half equation, while electron is found on the left hand side of a reduction half equation. In chemistry exam, they love to ask which element is oxidized or reduced. So to answer such question, always check the oxidation number and the movement of electron. That is the secret key. We have our CYK right here. Check your knowledge. Feel free to pause the video while you answer this question. Identify the oxidized and reduced in the combination reaction as shown in the equation right here. Alright, let's attempt this question together. What is the oxidation state of the zinc atom right here? It is the parent atom. What is the oxidation state of a parent atom? That's right, we have 0. Okay, and the oxygen atom here has the oxidation number of what? 0. But when they combine, there is an exchange of electron, whereby zinc donates electron while oxygen gains electron from the zinc. So when zinc donates electron, it becomes zinc 2 plus, and when the oxygen gains the 2 electron, it becomes 2 minus. Okay, so can we identify the oxidation and the reduction process? 0 to plus 2 implies what? That's right, oxidation. Increase in oxidation number. Oxidation. Why 0 to minus 2 implies what? That is right, reduction. We have reduction. Okay, that's a decrease in oxidation number is what? Reduction. Which atom is oxidized and which atom is reduced in the process? The zinc is oxidized, while oxygen is said to be what? Reduced. That's right, reduced. So the oxidized atom is referred to as what? A reducing agent. While the reduced atom is said to be what? The oxidizing agent. Oxidizing agent. So we've been able to answer this question correctly. Identify the oxidized and reduced in the combination reaction. The oxidized is the zinc atom right here, while the reduced is the oxygen atom here. The oxidized atom is said to be what? The reducing agent, while the reduced molecule right here is said to be the what? Oxidizing agent. Makes sense? In a displacement reaction, an atom A will displace atom B, thereby forming what? AY as a new compound, while we have the displacement of atom B. A very good example is the reaction of zinc with copper 2 tetrasulfate 6, thereby resulting in the formation of zinc sulfate, and we have the displacement of copper from the copper sulfate. So can we identify if this reaction is redox or not? Let's check our zinc atom right here, which is the parent atom. It has the oxidation number of 0. Then the copper in its combined state has oxidation number of +2. The sulfates as a group of ion has the oxidation number of -2. And the zinc in its combined state on the product side has the oxidation number of +2. The sulfate has the oxidation number of -2, while copper, which has been displaced, it is in an uncombined state, so it will have oxidation number of what? 0. So let us check the oxidation process and the reduction process in this displacement reaction. We have 0 to +2 is what? Oxidation. So this is oxidation. While +2 to 0 in the case of copper is a reduction process. That is a decrease in oxidation number is reduction. Reduction. Okay, which of these two reactants is oxidized and which of the reactants is reduced? The zinc atom right here is oxidized, while the copper sulfate is reduced. Since we have the oxidized atom and the reduced compound, which of these is the oxidizing agent and which one is the reducing agent? The zinc atom is what? That's right, the reducing agent. The oxidized atom is the reducing agent, while the reduced compound is what? The oxidizing agent. Moving on, I have another example right here of a combustion reaction. When a substance burns in excess supply of oxygen, we call it what? Combustion reaction. Here we have a methane burned in excess supply of oxygen to give carbon dioxide and water. Can we identify the oxidizing agent, the reducing agent, the oxidized molecule, the reduced molecule? So let us do this together. In methane, we have carbon and hydrogen. Right here, the carbon has the oxidation number of -4 and the hydrogen has the oxidation number of +1. Oxygen in its uncombined state will have oxidation number of what? 0. Then in carbon dioxide, carbon has the oxidation state of +4 and oxygen has oxidation state of -2 in its combined state. Then in water molecule, hydrogen has the oxidation number of +1 and oxygen has the oxidation number of -2. Now let us compare the oxidation number on the reactant side as well as that on the product side. Let's start with carbon. Carbon has the oxidation number of -4 right here, and on the product side it has the oxidation number of +4. That is an increase in oxidation number, -4 to +4. What process is that? That's right, oxidation. So we have oxidation. Then can we identify the reduction process? Oxygen has the oxidation number of 0 right here, while oxygen has the oxidation number of -2 on the product side. 0 to -2, that's a decrease in oxidation number. When we have a decrease in oxidation number, what process is that? That's right, reduction. So we have reduction process here. So on the reactant side, let us identify the oxidized and the reduced substance or species. The oxidized species is methane oxidized, while the reduced species is oxygen reduced. Okay, where is our oxidizing agent? Where is the reducing agent in this reaction? The oxidized species is the reducing agent, Ra, while the reduced species is what? The oxidizing agent, OA. Make sense? So I would like to give you another exam tips. Note that in precipitation reaction, double decomposition reaction, and neutralization reaction, there is no transfer of electron. That is, we do not have exchange of electron. Since there is no transfer of electron or exchange of electron in precipitation reaction, double decomposition reaction, and neutralization reaction, these reactions are not redox reaction. Make sense? Did you know that redox is everywhere? It is observed in photosynthesis in plants, respiration in your body, rusting of iron, as well as batteries and electricity generation. Yes, every time you breathe, you are doing chemistry. So in redox reaction, here is a trick to never forget. Oil rig. Oxidation is loss of electron, while reduction is gain of electron. And the other trick is Leo the lion says girl. Leo, lose electrons, oxidation. Girl, gain electrons, reduction. Make sense? I would like you to drop a comment, oil rig forever, if you found this video lesson so interesting. And if this lesson finally helped you understand redox, hit the like button, subscribe, and share with other chemistry lovers. See you in the next video, and thanks for watching.